Hello everyone, this is Dr. Purdue with Rimway Educational Resources, and today's screencast is going to be on an activity that I've used a lot with my geometry students on rigid transformations. Now, you may already know that rigid transformations, also known as isometries, consist of translations, reflections, and rotations. And I have this website here, which is what I usually give to my students. I'm going to have the link included in the description section of this screencast, so you can go to it as well or send your students to it. And what it does is it gives them step-by-step instructions on how to investigate these three transformations in the plane for themselves and determine that they are indeed examples of rigid transformations. So I'm just going to scroll through so you can see it. And again, I'm going to have this link as part of the description so you can go there. You'll notice there's lots of screenshots so students can easily figure out how to do the steps. And as they go along, there are questions in bold that you want them to answer, preferably in text boxes actually on their sketch. Now, this particular activity was modified from some original material that KeyPress did long time ago, and I just made it an online version. I'm going to also have links to some of KeyPress's new stuff because they've been adding to this collection of activities for a long time, longer than I have. And the main thing that I really want to convey in this screencast is what the students' sketches might look like after doing this activity. So here I have my Sketchpad document. This is what I use as the key when I talk to my students about this and when we review it after the fact. So the first thing that I like to see for them is a page where they have defined in their own words the different kinds of transformations. Now you'll notice that I have the left-hand side here with the non-rigid transformation included, but when I do this with my students, I'm really expecting that they focus here on the right-hand side, the rigid transformations and the three types that this activity is about. And you probably already know this. Transformations, of course, are just different kinds of movement in the plane. And the one that we usually focus on in K-12 mathematics now, because of technology, is the rigid transformation. And that's the one in which the original image and the new image that is created after the transformation, they are congruent, meaning they are exactly the same in both size and shape. And of course, the different kinds of rigid transformations are translation, reflection, and rotation. And because we're teaching this now earlier in the K-12 curriculum, we often refer to these three rigid transformations by their more common terms, which are a translation we usually refer to as a slide, because that most accurately defines the movement in the plane. The reflection we refer to as a flip, and the rotation as a turn. So here's the first page where I have constructed, using Sketchpad, the first rigid transformation known as the translation or slide. And you'll notice that I have some measurements here of both the original and the image, and I have some other information in the text box. And so this is the kind of thing that you would want to see from your students if they do this activity. You'll notice that right now, just looking at the screen, this could just be a static handout. It doesn't really demonstrate the power of the dynamic geometry software, like in this case Sketchpad, or if you're using the open source version, GeoGebra, or any of the other kinds of dynamic software, dynamic geometry software that's out there now. So let me just point out a couple of things. You know, we've talked about transformations being movements in the plane, and we've talked about the difference between rigid and non-rigid transformations being this preservation of both size and shape, meaning the original and the image are congruent. So in this case, the translation is defined by the translation vector. So you'll notice I have this segment AB, which is some length. I can actually find out precisely on my particular one. It's 17.4 centimeters in length, and it's pointing in some distance. And I have actually defined the vector in this case going from A to B. And so that means it's pointing, if you want to think about it like that, a little bit up and to the right of your computer screen. And if you notice, the original figure, this triangle here, has been translated or slid that direction for that distance. And that combination is what makes a translation. And the beautiful thing about this software is it lets you show all of that dynamically and lets the students investigate this in a much more hands-on way than what you could do before with paper or with patty paper. So for example, if I click on the endpoint here for my translation vector segment AB and I make it shorter, it automatically adjusts the translation, the length of the slide, to also be shorter, in this case 9.3 centimeters. Likewise, if I make it longer, or if I change the direction, so if I go down instead of to the right, or if I go more at a diagonal. So all of those are dynamic. In addition, the size, meaning the perimeter and area of my original, also can change dynamically with the image. So if I make the triangle much bigger or much smaller, or if I change the shape and make it an obtuse, a right, a scalene, whatever I do, those all will change with the image as well. And what happens is for all three of these rigid transformations, that is what we want the students to explore and to discover. So for the reflection, you notice I have the original here, and it has been reflected around this line now, AB, which is considered the mirror. And again, just like what we were talking about with the translation, there are some investigations that students can do in terms of distance. So if I make the mirror really close to the original, then the image is really close to the mirror. If I make the mirror farther away, I'm talking about this distance from the line AB to the original, then the image is also farther away. And likewise, if I change where this line goes, if it overlaps the original image, then the image overlaps as well. And all of these investigations, by the way, lay beautiful groundwork for another really important topic in geometry, that of symmetry. And then finally, the rotation, the turn, it's defined by a center point, which is the point around which the image is going to be turned. And for me, I've defined that as the point A. And then the other thing is it's defined by an angle of rotation. So if you notice, I have this angle CAD, and if I start out at 0 degrees, then the image and the original exactly overlap. And as soon as I open that angle to some degree measurement, it rotates that image again around the point A. So I hope that this sketch and this screencast has shown you a little bit about how you can use this activity for the Geometer Sketchpad or any of the dynamic geometry software packages to explore the rigid transformations in the plane. So thank you very much. I hope you enjoyed it.